So we're still at a very high profile development in central London, which has got a really, really good and impressive water reuse system. So the building's at its final development stage now, so practical completion will be happening in the next few months. This offers a great example because we've had lots of challenge on this particular site. So on this site, the initial phases struggled. They have a reuse system installed, it's in place, but it's not operational at the moment because there is issues with that particular system. They've been able to take the lessons learned from that particular system and apply it to the final building that's being constructed here now. So they've got a really good monitoring system in the basements. They've got clear demarcation, clear monitoring, clear labelling throughout the building to really kind of get a clear understanding of where the reuse system runs and how to separate that from the possible network itself. So it offers a really good case study in terms of the challenges faced by installing water reuse, but how you can overcome those challenges by really having a well-monitored system.
We've just been inside to look at the final tower as part of this phase development. There's 92 apartments in here, all of which have their WCs flushed with recycled rainwater. We've just been looking at the tanks downstairs, which have some quality membrane treatments, which they've taken apart as the non-potable feed up through the risers and feed on those WC. What's really clear is the labelling throughout. It's really easy to spot where the non-potable water is feeding and where that pre-treated grey water is flowing.
So here we see biological, mechanical grey water recycling systems. And it's more or less 3 stages of treatment. First one, you have a coarse filter here that takes larger particles out when the water comes from showers and hand wash basins down to the system. 99% of the water goes into the tanks. But there's a backwash element in there that, kind of operates on a daily basis, getting rid of the larger particles. The water then is stored in these tanks, and this system here, because of the head height room here, we're using fairly small tanks, and that's why you see quite a battery of them. And on the top there, you see these the beige little boxes. These are compressors that blow air into the water. And the aeration is a big part of the treatment. So 90% of the dirt is literally removed just by blowing air into the system. Yeah, but of course, after that treatment, we still have about 10% of the dirt left. And the other issue is, of course, there might be pathogens in the water. So therefore, that water is then lifted across to this tank here. And that's our, a filtration tank that fills up slowly. Yeah, we need to give time for the bacteria to operate on that water. And that is done by this tank here that slowly fills up. When that tank is full, pump sets in, that draws the water from that tank and pushes us through these membranes, okay? So this system here treats between, roughly, I would think 10 to 12 cubic meter a day. That water is going through these membranes. The membranes are 20 nanometers fine. So usually it takes all the bacteria and viruses out. The water then goes through the elements into these tanks, and this is the treated water. So this is the water then that's ready for use. You have 2 ways of cross connection, right? So you have one you could have on the distribution side, on the supply, or one on the collection. So on the collection side, you would suddenly get foul water into the system. Of course, as you can imagine, there's more dirt in there. So the membranes have to work harder. So the system starts backwashing more often. So that's one indication. And if we have oxygen level monitoring, and the oxygen levels would drop massively because the amount of organics in the water that need the oxygen is going to be high. So these are indicators for us where we know something's in the system that shouldn't be. And then we can come and have a look at it and find out what it is. If that problem happens, the system goes on mains water and keeps on supplying water. Nobody would even know about this, right? And so because it's not a crucial element, if the system has to change on the mains water, because that's where the mains water kicks in, making that emergency element and keeps everything running, and then you have time to sort your problems out. So we don't have to react, that quickly, because when it flex up the next day, be fine, sending the guy out, have a look at it. So there's 24 hours of storage or availability that you can cover.
Yeah, I think we're really focusing on this building because this building offers us a fantastic opportunity to get a real good insight in terms of the value of water. So we think we've got smart meters across this whole estate. We can actually start monitoring really closely how much potable water is being used in this building versus how much non-potable. If we can start applying that in terms of the number of people living in this estate, so we can get a really good insight into actually how much water is using, because up to now everything's very much guesstimated. So this gives us a real good opportunity to try and see what's actually happening, and we can really level it to an apartment, and we'll be able to see from the usage in each of the apartments whether that reuse system is operational or not. So this will give us a real big insights. it really needs to focus on the stewardship. So who's actually going to own, operate and maintain these systems? So it's great it's been installed in this building. There's still a big risk that once this building gets fully handed over, that management company may not be fully aware of the system, how to operate, how to run it. So there is that risk then after a while, it may get shut down. So the key thing we need to focus on is once we've got these things agreed and these systems are going in, how do we make sure they keep going? How do we keep them maintained? How do we work up a model which understands how these things can be funded? And that's the challenge. What is that ownership? What is that financial model associated to these types of systems? So the system was installed and Quality can do the monitoring, but how we effectively charge, how does the end user pay to ensure that this system remains operable?
I think until this becomes mandated, this is always going to be an optional extra. Fortunately, it's been installed here, it's been installed really well here, and we'll be monitoring this throughout occupation. Until it becomes mandated, there is no driver for it to be maintained, to be still switched on. We need to make sure that this is continually operating so that we can reduce down the water demand associated with developments like this. And therefore we can develop far more and meet the government's growth agenda associated. Until it's mandated, this is always going to be an optional extra, and there's always the option to turn it off. We need to remove that.